and remind you to type your names in chat as things go on here. And let me go right into sharing screen here. Clean up this stuff here. All right, so we're talking about the wheel collider, which is very different from all the other colliders that are geometry. The wheel collider is this fancy thing that maintains contact with the ground, calculates friction, has a suspension with springs and dampers, and it has settings for how much torque will be applied, and we have access through scripting to the motor that makes the thing go, and the steering that turns the wheels. And we were talking about how to set up the making a car. And so we went through the procedure of setting it up. And this, of course, is just making sure that all of the wheels have their Z direction pointing forward and their Y direction pointing up, and placing them around our car. And we wanted a script that would apply torques to this. So we had a list of axle infos, and in order to have access to the list, we needed the system collections and system collections generic. We have exposed motor torque and steering angle. And in the fixed update, which is where one applies physics, we caught the vertical and horizontal axes, which are the arrow keys and the W, A, S, and D. That's my dog, sorry about that. And we then went through all of the axle infos with a 4 each. And Liba, hey, Liba, come here, hey. We went through, and whether they were set to steer or be motor, we would assign the steering angle and the torque, and this is what drove the car around. I did mention the serializable class that we defined for the axle info that has left and right wheel and Booleans for motor and steering. The reason, Liba, stop it. The reason we do this is that this then shows in the inspector as a, this is the list where we can specify the size, drop in left and right wheel, decide whether it's a motor or not, left and right front wheel that we make steering, and set that torque and steering angle. So this is the reason for that serializable attribute. And I think what we were doing was setting up the visible wheels, which we did by adding a little piece to it, apply local position to visuals, that takes a wheel collider, finds its child, and then sets the position and rotation of that visual wheel to correspond to the pose of the wheel collider. We use this get world pose that has output, position, and rotation, and we could then assign to our visual wheel that position and rotation. And so the visual wheel then looked like a proper wheel. And I was showing you this example here where we have our wheels. Let me get the front left here. So we have our wheel, and I have this visual wheel that is a flattened cylinder. Now look at the axes here. The RGB, XYZ, the blue one is the forward. And so we have it pointing forward and the Y pointing up. But if I look at this flattened cylinder, because the cylinder axis is along the y-axis, and I've put this into V visually where I want it to be. When I run this, is going to orient the wheel to match the pose of the collider, and of course that's wrong. And so that makes our little paddle wheel boat that floats around. So a fix for this is to instead the child of our wheel is an empty game object. And this is oriented so that its forward and up vectors coincide with the wheel. And inside that, as a child, is a flattened cylinder that has been rotated 90 degrees in the z-axis, so that when this wheel gets put in the configuration of the collider, this thing will come along with it, but rotated by 90 degrees. And we then have this fixed little car that has proper wheels. So, so that fixes our car using a cylinder. Another way to do this would be to use a flattened sphere or actual mesh object that has a proper cylindrical shape with the right axes. So let me show you a scene here where I've taken this to extreme. Because that list has an assignable number of slots. Let's see. So here we are on terrain. This is that car that I just showed you, maybe with a little more torque, I'm not sure. But these little cars drive across terrain and bounce and do all kinds of wonderful, intuitive things. As I mentioned, because that is a list on this car, I've specified that I have 3 axles. So I have a rear, a middle, and a front. And so now I've got this little 6-wheel car that drives around my terrain and looks more and more like a tank that is kind of fun and cool to play with. And of course, I don't think there's any limit on how many axles you put on it. Here's a 6-axle car. With the front 3 steering. I believe they're all motors. Whoops. I have a little escape here. If I press the escape, it flips the car if I get it stuck upside down. So lots that we can do with our little cars. But that's not all we can do with cars. Here in this scene, I apologize. Ordinarily, I would load these all up, but I crashed my computer doing that the other day, and I don't want to repeat that. So we just have to wait through it. So some of you did the robot lab, and in the robot lab, there was a little doodlebug car that was a waypoint follower. It threw kind of random positions, and it navigated using the nav mesh to those random positions. And I liked this little car, and so I ripped it out of the robot lab and set it up. It turned out to have detachable wheels, and so I was able to set it up using the same tools that we had, that we just defined. It's got the different wheels, and this one, I believe, is set up to be a little drift car. So it slides quite nicely, and so it's a little drift car. But by just changing a few of the settings in the friction of the different wheels, making them more sticky, I have now this car that has more sideward traction than it did. And so now we get this kind of bouncy rolling behavior. And we have another different car. And this was all done by just changing the friction settings in the wheel colliders. I found a truck. This one did not have detachable wheels, so I didn't have any visual wheels. So while this one does drive around like a proper truck, its wheels don't turn because the model itself didn't have detachable wheels. I did find a nice kind of tractor trailer truck here. I won't bother to play that one, but what I did was I made this, I attached a trailer to it with a hinge joint, and it has wheel colliders in the back here that are just passive drag along wheels. But I now have a tractor trailer truck that I can drive around, and its little trailer connected with a hinge joint follows along behind. And of course, because I have way too much time on my hands, I made a double trailer tractor trailer truck that I can drive around this terrain here. And as you remember, the hinge joints, the joints are all breakable. So if I can jackknife this truck, if I can jackknife it and break it, well, anyway, bottom line is if I jackknife the truck, I can break those joints and lose my trailers. So, and all of these were done with just that simple little tool, that little script, 20 some lines long. Now, the standard vehicle, the standard asset vehicle that comes with the 2017 standard assets is itself a very sophisticated car or vehicle. Come on, open. And somewhere in the asset store, I found this set of cars. I believe they're called Mobile 10 cars. I got it through some discount thing. I think it cost $15, but it has a bunch of different cars. And happily, all of these things have their own detachable wheels. So they have a body that is the visual of the thing, but they have 4 detachable wheels. And so I could take the standard car, and this is the standard car, which is a very fancy tool. It's got brake lights that function. It has a bunch of, it has a much more sophisticated physics setting than what we did in that simple making a car script. It does things with particle effects, laying down these skid marks. And I believe it actually makes a bit of dust as it traverses certain kinds of terrain. So this is a very sophisticated physics model of a car. It has settings for the different wheel colliders. These are the colliders. And it has settings for the visible wheel meshes. These are the visible wheels that are part of my car. And the wheel effects, of course, are the particle effects that we put on those wheels. It has settings for the steering angle. It has a thing called a steer helper, which I believe is like a anti-sway bar on the car. As the car tilts, it puts more weight on the interior of the curve, so it makes your car handle better. And there's a traction control, torque settings, downforce, top speed, and it actually has a fairly sophisticated audio system too. So it makes different sounds depending how the car is accelerating. So taking this thing, I stripped off everything but the wheels. So, and I did this in a very simple way by just kind of turning off. This is the Sky car part of the thing that has the visuals of the body and the lights and so forth. And I left the wheels here because I'm using those wheels, but the car itself, I was able to just disappear, turn them off. And so now I have a basic chassis that I can drive around. It works just like the car. It does the skid effects and everything still, but I can put whatever car I want on it. And so with this, and a little bit of fiddling, my Kabara here, I'm using the wheels that came with that model. Happily, they were separate, and all I did was put them in the car controllers slots for the wheel for the wheel meshes, those objects that went in there. And now I have any of those cars that came from Mobile 10. And of course, the wheelbase is different. They have to be positioned right to look good with the body and so forth. So I have that set up. Here's this little doodlebug car that comes with it. This little doodlebug car is kind of fun. So, and its handling is different because of that. The SUV, of course, I could play with the suspension settings on my different wheel colliders. So I now have a kind of long throw, bouncy suspension, as you might get with an SUV. And just to show you what that steering helper does, here's with the steering helper turned off so that it no longer is helping the steering. And my car is now a whole lot tippier and I can actually crash it. So a lot of cool stuff. And that's just with the standard car using their script and their suspension setup with the appropriate visible wheels from the different models. Now, one of the other things that's kind of cool about the standard car is that in the standard assets, there's an AI car that uses that same script. It just has a different controller that is an AI controller, and it's set up to follow waypoints. which we'll talk about when we get to AI, setting up AIs to follow paths around within a world. But of course, one can use that to make racing games. And I make all these racing games where the AI cars race against each other because I'm not very good at driving them. But here's a whole flock of AI cars. Those are those Model 10 cars, and they're going to race around this track. And I have a little scorekeeping thing. The camera stays on the leader car here. And there's a scoreboard that's keeping track of who's in the lead and so forth. And of course, I had a lot of fun with that. Now, that's not all there is. There's also something called the vehicle tool, which is a Unity Technologies asset. You can get this from the asset store. It's free. And it's a completely different physics approach to vehicles. It's different than the standard assets. And one of the nice things about it is it has a car creator tool. So you can just kind of make a car on the fly here, and it makes kind of a basic car. It comes, I think, with 3 standard things that are already set up and ready to go. It also has, whoops, that's the wrong scene. It comes with 3 basic vehicles. What is it? Space bar is the camera. So it comes with 3 basic cars, a truck, a sedan, and a sports car. And these things are set up to drive in an ordinary fashion. What's kind of nice is this tool up here that shows the slip between the wheels. It shows how those wheels are behaving. It's a little tool that lets you do that. Now, as I mentioned, the nice thing about this is it's creator. So it has this vehicles pull down where we can create a skeleton of a car. We specify how many axles, how much we want it to weigh, what the distance is between the axles, how wide the axles are, and I forget what the shift is, but this generates a skeleton of a car. So here's the skeleton of our car called car root, and it comes all wired up, whoops. It comes all wired up with wheel colliders that are set according to those specifications. And it has this tool, the easy suspension, that lets you kind of adjust what you want the frequency of your bounce to be and how much damping you're going to have and where you want that force to be applied. And it has a wheel drive that has a slot for the wheel shape that you're going to put on this. So under vehicles, I've got a family car tire that I can put in the slot here. And I'm going to set this to be tagged player because I'm using one of the standard assets multi-purpose camera rigs that automatically targets the player. So it's automatically figured out that it's going to watch my car route. And just so that the little graph shows, I'm also going to drag this little car that I just made over in here. And that fast, I've made a car that has wheels and that we can drive around the scene. And I could, of course, set the torque up to be much more interesting. Where's my scenes? In A test and B test, I've got some other cars that I made, but of course, I'm not going to save that. Of course, one gets carried away with cars with lots of axles. This is 10, which is the maximum that it will make. And so this makes a big 10-wheeled vehicle that I can drive across this landscape. And it's actually a pretty interesting vehicle that can traverse rather rough and bizarre terrain, and it does it all with physics, and it's very, very cool. And so that's a lot of fun. And this is a free asset from the asset store. I highly recommend it. So I used that in this scene. I found a model of the Mars rover, not Curiosity, but the littler earlier rover. And I noticed that topography from the vehicle tool had this kind of reddish tinge. It looked like Mars. I found a skybox that looked like Mars. I think it actually is Mars. This is a Martian skybox in the background here. And I'll show you more about this later on, but this is an autonomous vehicle, of course, since the rover is not driven by hand. So this is, again, one of those nav mesh tools that finds a path across a landscape, and the little doodlebug rover follows that little dot that's there ahead. Down here, you can see the path that it has planned for itself to get up the terrain to the marker that it's trying to go to. But this is just an adaptation of one of those vehicle toolkit cars, and it steers and has 6 wheels, and it negotiates this terrain going from one waypoint to another using nav mesh, which is a fancy tool that we'll get to later. So I had a lot of fun with that one as well, but that's way beyond what we're doing here. That's just a fancy example of a car. So I think that's it for cars. So let me stop here and entertain any questions about the wheel collider and the vehicle tool and the standard asset car and our simple script to make a car. Any questions? No? Okay, so I want to backtrack a little bit here. I didn't get to some of the things I wanted to do with particles back when we were doing particles. So making particles is not that hard. We start off with some texture that we develop. I found this snowflake on the internet, and with a texture editor like Photoshop or GIMP, you can take that texture and delete all of the background that you don't want to see. Photoshop and GIMP have tools for doing that fairly easily, so you can delete all of that. And then making a fill layer, you can put this black behind it. And the black, when we import this texture, that black is going to be transparent. You can save it in whatever format, PSD or JPEG or PNG. Unity will import PSDs, the Photoshop native form, but they're big, whereas JPEGs and PNGs are much, much smaller. So when we get that texture, here's my texture, and we want to import it as a 2D default. We want the alpha source to be from grayscale. So black is going to be 0 on the grayscale, and that's going to be transparent, where all of these other colors will, in their grayscale, will be visible. And so we do those various settings and apply. There are things that you can set for what the size of the texture is that you're actually using in Unity. So if you have a big high-res image, you can set its size in Unity to be whatever you want. And then you need a material to put this on. And so here are a number of different materials. This one used one of the legacy shaders for a particle additive. The shader we choose from this shader menu. And in addition to the legacy shaders, there also are the newer standard shaders. This is particles additive, particle soft, and particle alpha blended. And each of these looks a little different because of the way transparencies are combined in Unity. These are just the little examples here of those 4 different shaders in use, but it's very simple to make particles. And of course, here's a scene with a snowstorm using those little particles, the snowflake particles. And I believe there's a sub-emitter that when they hit the ground, they make a particle that is horizontal billboard flat on the ground. I made another particle for a raindrop. It's just a little cartoon kind of raindrop. Cartoon raindrop. And so in this one, I have these raindrops falling, and there's a sub-emitter that makes a little burst of particles so that you get kind of a splatter effect when the raindrops hit the ground. I think they have trails too and some other tricks. So making particles, pretty simple. Now, the other thing I want to go back and talk about with particles is particle lag. Because particles are not free. Particles are not free. Particle lag. So particle lag, they're not free, although they are much less expensive than mesh objects that have rigid bodies and colliders. And I've set up some example scenes here that kind of stress test the particle system. And I'll start off with a flat plane with a collision module here. These are particles that collide with the plane. It turns out that collisions is probably one of the most expensive parts of the particle system. Up here is a little frame rate counter that's a prefab in the utilities of standard assets. It counts the frame rate. It's a little more accurate than the stats count of the frame rate. The stats only looks at one little part of it, but this is actually the whole thing, the rendering. Now, I had 10,000. Oh, the other thing about testing this is I've turned off something called VSync. And VSync is a feature of Unity that throttles the frame rate to 60 frames per second. It makes sure that Unity's projection of a frame occurs in sync with the monitor's projection of the frame. And you do this because if you don't synchronize it, they can get out of sync and you can have artifacts where it kind of tears the screen a little bit. They're hard to notice, but somebody there would notice. So here's the documentation on this tearing effect. So this is in project settings, quality, and you can have it set for every blank. This would be with every vertical blank of the monitor screen. You can do every second blank. And I've turned on don't sync, which means this runs as fast as possible without throttling it. So here's that same scene now, except I'm using a world collider instead of a plane collider. And the world collider is more expensive. It uses a completely different physics mechanism to detect things that it's going to bump into. It uses raycasts instead of geometry. And so its frame rate here is much, much lower than it was when we were working with the plane collider. With the plane collider, we're getting over 100 frames per second with the same number of particles. Now, it gets worse with terrain. Here's a terrain collider instead of a plane. And I think this one actually starts to lag at about 1,000 particles. So about 1,000 particles, and we start to see, well, we're definitely seeing lag there. That's because we're running with zoom on. But the collider has different settings, high, low, and medium. And so if I set it to the low quality, it now doesn't lag as badly, but it's leaky. The particles leak through the terrain. Not all of them. Some of them get caught, but not all of them. And so these are different instances. Now, another place that we might use particles is with mesh collider or with mesh particles. So here are a bunch of cannons that are shooting these mesh objects. These are mesh particles. They're not physical objects. They're particles. They've got sub-emitters and all the different tools, and they do a lot of stuff without producing a lot of lag. And one of the reasons we do this is because having a gun that fires physical objects. So here, these are the particle guns. I've got a whole array of them to stress this thing. And I'm running at 30 to 40 frames per second. And if I now turn on the object guns, it goes down into the 20s. If I go to the profiling view, this is a tool that Unity provides for us, and I should start this over again here. So with the profiler, I can look at the cost of rendering, scripting. The rendering is the green, the scripts are the blue, and the physics is the yellow. I'm going to turn off rendering because that's going to be basically the same. But I can see here that I'm counting how many things are hitting the end here, and the particle gun is getting way ahead of the object gun. The object gun is kind of lagging behind. And watch what happens to these different curves as I toggle only the particle guns. So A, my scripting load went way down. B, my physics went way down. And now if I go back to the object gun, the physics, the orange part there particularly, goes way up. And if I go back to the particle gun, those go way down. So clearly, sending out a whole bunch of mesh particles is a much better idea than sending out a whole bunch of instantiated game objects like you did in the brick shooter. In the brick shooter, we were instantiating physical objects and throwing them out into the world. One little feature of this, in one of those particle lag scenes, I've instrumented the FPS counter to actually output stuff. And this uses system IO. We're adding system IO here, which gives us a stream writer. And then in the update function where it's accumulating the frame rate, I can write that out to a file on disk. And so using that little tool, I could then instrument this. And here I ran up to 200,000 particles. And on my old laptop, it ran at about 120 frames per second up to about 30,000. Then it kind of fell off, leveled out here, and went down to about 60 frames per second at about 140,000 particles. And this is the same results run on my newer laptop, which has a Radeon Pro 5500M, whatever that means. But with that, I was getting 250. And again, at about 30,000, it fell off the map here and the frame rate declined. But I was getting the nominal 60 frames per second right out to about 160,000 particles. And I won't show you that one because it takes a long time. But if you want to stress test your system, go right ahead. The collisions I mentioned are the most expensive part of particles. Particles that don't collide are fairly cheap and you can run a lot of them. But if you have collisions going, that costs you a bunch. The plane setting is the cheapest to run, but it suffers from the following drawback here. Boy, with Zoom running, it just soaks it up. Oh, I know what it is. So here's a tilted plane. And the thing about the plane colliders, we set them, we have to give them an object whose XZ orientation defines the plane. The plane is infinite. And so even though these things have gone off the physical plane that defines that horizontal surface, they're not falling properly when they get to the end. Of course, if I do this with a world collider, it's now properly colliding with that plane. I'm seeing considerably more lag with these particles, a lot of lag here, mainly because we're running with Zoom. But when it gets to the end here, it does a proper cascade off the end. So world colliders are expensive, but they're worth using when you need them. So one of the tricks that I did there was with the particle guns down at the end of the row, there's an object that is counting how many particles hit it. And so it has a script on it called hit by particle. And it uses a function called on particle collision. And on particle collision returns the game object that had the particle system on it that produced that particle. And so if the other's name is gun name, the gun, that the particle gun that is the object, it counts them and displays them in a UI that we'll talk about in a little while. It does do one little, no, not there. Okay, so particle lag is something that we have to deal with. So I'm going to stop and entertain any questions there. Any questions at this point? That particle lag thing, I'll post it and you can stress test your system, see what kind of frame rates you get. And remember that the VSync has been turned off in there, which can produce visual artifacts. And so you would probably not want to have a publication game that had the VSync turned off. But it's useful to get an idea where the lag is in your system. Any questions? All right, well, I don't really have enough time to go into this, and actually it may take as much time to load the next one here. But I want to talk about sound in Unity. Back when we were doing two cameras, the picture-in-picture, I warned you that one of the things you have to do is turn off the audio listener on one of the cameras, because otherwise you get this continual error message or warning message that tells you that you have two audio listeners. The audio listener is where in the scene sound is picked up. And we're going to find that sound in Unity is three-dimensional. It diminishes with distance from its source, the component, the audio source that we can put on objects. So we can have bullets that make sound. They'll make a sound as they travel through the air, and we will hear them when they come close to us. And the sound is actually three-dimensional in the sense that if you've got headphones on, you can hear the sound in the right and the left. So lots of fancy stuff with the sound. I believe in the assignment for this coming week, I asked you to look at the audio mixer. I'm not going to deal with that in class. The audio mixer is kind of an advanced TMO, too many option tool. It's comparable to the particle system, but it's for controlling audio. Audio is pretty simple though. Here I've got a little scene, I've got a little cube, and on this cube, I've added an audio source. And in the audio source, I've added an audio clip, the boom clip. And I'm not sure what'll happen with this. It's not making any sound. Do I have mute on? I don't know. All right, well, I can't hear the sound that Unity's supposed to be making here, but all I have to do is add that audio source, add that boom, and when I play this, this should be making a sound, but there's something wrong here, and I can't hear it in the world here, which makes the rest of the lecture kind of meaningless. And I'm out of time anyway. But I'm gonna talk about audio, and hopefully I can figure out how to make it work in in Zoom. I don't know what's wrong with it. All right, so I'll stop sharing there, entertain any questions, remind you to type your name in chat if you haven't already left. And I think I'm going to stop recording at this point.